Hi, my name is Ben Freireich. I'm the Technical Director at Particulate Solid Research Incorporated, PSRI, in Chicago. And today I'm talking with Heinrich Jaeger, one of the plenary speakers at the World Congress of Particle Technology from the University of Chicago. And he gave a plenary talk on contact charging, electrostatics of particles. And we're going to sit down and chat about his talk. So thank you for joining us, Heinrich.
Yeah, thanks for having me, Ben.
Good to see you. So your talk, tell us briefly what are the new findings that we have in terms of contact charging of particles?
Well, maybe I should set that up. Contact charging is really one of the most pervasive phenomena that we have in particle science and particle technology. In fact, what I like about that is that it involves both fundamental aspects. So we still are struggling with figuring out exactly why certain materials charge, how they charge, what actually happens in the charging process. But then charging underlies so many applications, from particle technology that we use here on the planet, but also all the way out to asking really fundamental questions about how did planets actually form. So it's a wonderfully rich spectrum.
Wow, okay. So where do you see the future of understanding of contact charging going?
Yeah, so one of the, I think, important challenges right now is to go beyond phenomenological approaches to reach a good understanding of what actually is the carrier of charge that moves from, let's say, one particle to another. We understand a lot what happens when we deal with, let's say, conducting particles. But as you know, of course, industrially, dielectric insulating particles are really a huge fraction of the market, and we need to understand really what happens in the process when particles of this nature collide, and we need to understand really, basically, we need to understand what transfers charge from one particle to the other. How can you get chemically identical particle systems to develop large amounts of charge? That's a tremendous challenge right now. On the other hand, I think there has been some progress made recently, for the last 10 years or so. I would say that in part this has come through development of better measurement technology. We are now able to get to tracking individual particles in situ, how they cluster, how they aggregate, how much they charge. We can track that, and that's a big advance.
That's exciting. That's exciting. So when you have charge transfer, you said we don't know exactly what's charging. So it could be electrons or ions or maybe
bits of materials, exactly.
Material.
So those are the three leading candidates right now. There is evidence for all of those. We have to sort out which kind of material or what kind of condition will lead to which mechanism. There is tremendous interest right now in figuring out exactly whether or not it is electrons or ions in particular. And where our group has come in lately is by developing methods to track the evolution of charge on individual particles. And then, given that there is not just one kind of charge, but distributions of charges in such a colliding system, tracking how one particle connects with another, slowly builds up larger and larger clusters. So that's kind of what the excitement is
exciting.
As far as I'm concerned right now.
That's great.
Yeah.
So if your audience could have one takeaway from your talk, what would it be?
Oh, that's hard, right? It's an exciting frontier. It has a long history, but it is still full of surprises, and it is a tremendously important area where I think the ability to track individual particles and watch the evolution, the charge evolution of individual particles will make a big difference. And so another takeaway actually is that if you thought that only plus and minus particles would attract each other, think again. It is perfectly possible that particles with the same polarity can still attract each other when the difference in charge magnitude is large enough. So this is very important also for practical
Oh,
applications.
that's
Yeah.
amazing. Well, thank you for sitting down with me. Thank you for
Thank you.
giving the plenary talk. And thank you for coming to the World Congress in Particle Technology. So,
Thank you.
thank you.